Mr. Phillips, it is great to see you. Welcome back, and thank you for coming back and finishing the conversation that we started a while ago. Um, if you recall, we had a bit of a conundrum where I asked the dumb question, and we didn't have a good answer for the dumb question. So we went back to the drawing board, and I think we have the answer. So if you would permit me, I'd like to ask the dumb question again.
Yes, sir. And thank you for having me back, Mr. Odell.
Okay, so the context of the question is we were talking about ghost reflections, and you made the statement that oftentimes your ghost reflection will appear smaller or be minimized if you used a longer jumper, for instance, a 75-foot jumper as opposed to a 6-foot jumper on your MTDR. So I'll ask the dumb question again and give you the opportunity to answer it. So, Chuck, why would your ghost reflection be smaller with a 75-foot jumper as opposed to a 6-foot launch jumper?
So, if I can clarify, first of all, and I go through this during my entire presentation, uh, the smallest recommended jumper on any TDR really is going to have to do with whatever is your smallest blind spot is on your smallest pulse width. However, there are some times that you really should use a longer jumper. And the way the context of this was, some people find that they have a lot of ghost reflections inside their cable, some do not. So if you do, I recommend you use a longer jumper to help minimize this. And the question, of course, was, well, why does a longer jumper minimize that? So picture this, the way the TDR launches its signal, it sends out a half pulse of energy, which of course is pushed by voltage. Now, the blind spots inside the cable tend to happen the most on your smaller pulse widths, all right? So a smaller pulse width has less time for the voltage to build up. Now, when it hits an impedance imbalance, mismatch, or an event, it sends half that energy back to the TDR. So now half of that energy is leaving, right? So let's say you have something like a DC. Half your energy is going back to the TDR. And when you get to the DC, literally your signal is being split in half, right, for a TDR. So literally your signal is going in two different directions. So you have to do something to give it more energy. Now, of course, you can increase the pulse width to give it more energy, right? But then you have other issues. So let's say we're talking about a short piece of cable. You have the voltage hitting the first event, but it returns back to the TDR quicker before it sends it back out again. So if you use a longer jumper, it quite literally dissipates that energy, thereby, I used the word attenuate. I don't know if that's accurate or not, but you're now eliminating the back and forth confusion that the pulse gets by going back and forth all the time. Now, when I mentioned using a 50 or a 75-foot jumper, that number is just an about. It can vary. So don't get stuck on the why does it have to be this particular distance or length, I should say. But that does tend to minimize it a lot. And also, one of the things that I share with people is, I'm not saying you have to use a 50 or 75-foot jumper all the time, but just make one and carry it with you. And when you notice, those might be ghost reflections, put your longer jumper on there. And if everything still appears where it was, but those possible ghost reflections disappear, that was a red flag for you that they were ghost reflections. Just carry it with you. And
So,
another piece of advice I'd like to give, if you have access to a head-end cable, I realize everybody wants to carry around as little equipment as possible. If you have access to head-end cable, 75 feet of head-end cable is nothing. It takes up no space at all. I'm sorry, go ahead. Go ahead.
no, no, no. I was actually going to reflect on one of the things that I used to do when I was still in the field is I would carry a 100-foot jumper and Series 6 cable or Series 59 head end cable. You can keep it from, exceeding the minimum bend radius and still create a pretty small coil of cable. And if you know exactly how long it is, like I used 100 foot just because it was a nice round number. and it rolled up pretty nice, and you can zip tie it together and keep it in pretty easily in your truck. Um, but to your point, it helped define things like particularly in underground situations where you don't have a lot of cable to work with, where it's coming out of the pedestal or coming out of the ground into the pedestal. A lot of cases, the radial cracks happen right below the surface of the dirt, right where
Absolutely.
it starts to bend. And sometimes, depending on the pulse width that you're using, you can't see that close to the end of the cable. So I would carry that 100-foot jumper, you know, mark my end of my 100-foot jumper, connect it to the cable under test, and then you can see, the cable very well, uh, pretty close to the pedestal or to the end that you're testing. But the more I thought about this after our previous session, is it makes sense, right? In cable, we're pretty comfortable with attenuation and frequency. So attenuation is a function of frequency. The TDR sends out a pulse of energy at a particular frequency. The cable that it's traveling through has an attenuation factor at that frequency. So the farther it goes, the more your transmitted pulse from the TDR gets attenuated, quite frankly.
Yeah.
And then when it hits a reflection and the reflection travels back through the same cable, at the same frequency, that attenuation happens again. So the more energy that you send is directly relevant to the size of the reflection, the size of the cable, attenuation at that frequency. And it's also not uncommon that we see second and third order distortions in receivers, which, as we talked about, the MTDR is both a transmitter and a receiver of a signal. And sometimes when a lot of energy gets um, transmitted into the front end of a receiver, the receiver itself gets a little bit overwhelmed with all that energy and creates distortions itself. And so I think there's a lot of things at play here that explain why we sometimes see those distortions and why adding more cable onto, the output of the transmitter of the TDR and then inversely the input of the receiver of the MTDR can help minimize those ghost reflections. So I think we knew the answer the first time. We just didn't,
Didn't know why.
yeah, we just didn't pull it out of each other. So
Yeah.
I'll take the blame for that one, Chuck, as a bad host for not pulling that answer that you knew out of you.
No, no,
But
no.
it gave us.
Thank you for asking. Because I actually, Mike, I do get asked that question from time to time, and I will tell people in the middle of a class, you know what? I think I used to know the answer to that, but I just did it because. But the fact that you held my feet to the fire on that, and I better come up with an explanation on that. I appreciate it.
Well, we'll get that posted as a follow up to Stump the Chumps, and hopefully we'll get some good feedback from our audience. And oh, by the way, audience, if you do have other questions for us about MTDRs or anything to do with that, it'll give us a good excuse to get together and talk again, Chuck.
Because we enjoy doing this.
That's right. All right, my friend. Well, thank you very much for taking some time out of your day to follow up with us. And as always, we appreciate Springbok and your partnership here at the Penn Ohio chapter.
And thank you as well. Enjoy the rest of your day.
You too.